I don't wanna grow up, I'm a curious kid. The world has 100 questions I can play with. So I'll open my arms and eyes and wonder every day till the day I die. No one really knows why gravity exists.
My name is Tucker Hiatt. I'm the founding director of this Bay Area beacon of science, Wonderfest. All right, tonight's Wonderfest speaker is Dr. Gregory Tranah, professor of epidemiology and biostatistics at UCSF, UC San Francisco. Dr. Tranah is also scientific director of biobanking at Sutter Health. Greg earned his PhD in ecology at UC Davis, and he completed postdoctoral work in epidemiology at the Harvard School of Public Health. At Sutter Health, at their California Pacific Medical Center Research Institute, Dr. Tranah helped direct the personalized medicine program, where his research involved the genetics of cognitive function, osteoporosis, osteoarthritis, muscle function, and most important tonight, sleep and aging. Greg is now a Wonderfest veteran, a repeat offender from several past events. He gave excellent Wonderfest talks, both here and in the East Bay, on health span in general, that is, the healthy version of lifespan. Please welcome, for his next Wonderfest adventure, to explore the health span issues of sleep and recovery, Wonderfest's healthy aging expert, Dr. Greg Tranah.
Thank you for having me back. So if you've seen me before or not, I've spoken at many of these on various aspects related to aging, healthy aging, maybe longevity. This is a series of talks I give other places, including my gym. Just full disclosure, I have nothing to sell. I have no products. I'm not going to try and sell you supplements. I'm just your friendly neighborhood epidemiologist who likes to share. So tonight we're going to talk about sleep and recovery, because recovery is something that's related to exercise, and so I think that this is important. But I want to set the stage with kind of the lens on age and aging, because everything I talk about is really related to the aging process. I think age is a number. This is the longest lived human that's been documented. She lived to 122 years old. And so we have, there are a lot of people in the Bay Area who are trying to become immortal or live forever and, trying to live longer than this. I speak for most of my colleagues in aging research that we really focus on health span, meaning functional aging and healthy aging. And this gentleman on the right, who I show in every one of my talks, he unfortunately passed away in July at 114 years. He was the first 100-year-old to complete a marathon. Just look him up on Wikipedia. The guy's amazing, and he was run over by a car in India at his home village, so he didn't even die of aging. So, but he's an amazing person. And so when I think of aging, I think of this person who remained functional for a long time. So when we think about aging, I do work from DNA all the way up to people. And so we think about all the things that kind of go wrong in the cell, with our DNA, with other things. And so we're trying to understand how all these different changes to our cells, again, to our DNA and things, impact the aging process. And so, you always see in these pictures, these publications, this kind of lifespan thing. And I really hate that they always end up with somebody like with a walker or something like that. And I really think that aging should get a new representation, right? Something healthy or somebody dancing or something like that. So if anybody out there is a graphic artist, please help me, because I think we can do better than this. But those things that I showed you before, like damage to DNA and mitochondrial function and things like that, are what is happening to our body. But aging a lot of time manifests as conditions that can come about in many ways as we age. And so this concept of geroscience, we're just down the street from the Buck Institute, my colleagues there study this, is trying to understand if we can address many or all of these things that underlie aging, then we could potentially delay or even prevent all of these conditions that we care about with aging. Because, most healthcare is treating these things, but we really need to put the health back in healthcare, which is keeping us healthy, not waiting for these things. And so that's, again, where people who study aging, this is what we think about every day, even though I might be looking at DNA sequences all the time. Okay, well, what can you do to stay healthy? There's no pill. There may never be one. But the good thing is it's all under your control. You can do all the things to keep you healthy for as long as possible. And this is the foundation. We already know the basics, right? Sleep, we'll talk about this tonight. Good nutrition, and being active. Some people would put community on here or human contact. I wouldn't disagree with that. So, do these things and you live well. So, good night. It's been a fun talk. No, but tonight I'm going to really go over what do we know, especially in the realm of sleep. Like, what does the data show us? What are the recent findings, and how, most importantly, can everyone here benefit from science, from data? So I'm going to show you data, and please stop me, slow me down, because I'm going to show a lot of information, but I'm going to make it hopefully easily understood and accessible to you. So we're going to talk about sleep, but we can't talk about sleep without talking about circadian rhythms, because there's not a daytime you that switches into a nighttime you. There's one 24-hour you that you really need to think about throughout the day. So you get up in the morning, you have your day, but then you prepare for sleep, and just like you prepare for your day, you have to prepare for sleep. And so biological rhythms are a fundamental property of every living thing. The most ancient organism on our planet has a biological rhythm. There's a reason for this, because a lot of things happen during the day, let's say, if you're awake, and at night when you're asleep, and you're going to be experts in all this by the end of this talk. But this is something that everything has, so that must mean it's important. So if this is so conserved across every living thing, what's happening? Like, why do our bodies do this? And so if you look at our bodies have clocks built into pretty much every organ and every cell. And I'll tell you how these clocks work. But at the larger level, we have things like muscles, our organs, heart, all these, the immune system even, and our brain, all have these clocks. And these clocks are governing a rhythm where sometimes some genes and proteins and hormones are produced, and other times they're not, over a roughly 24-hour day. It was thought for a long time that it was all conducted by one master regulator or conductor in the brain that was processing light to set all these clocks, but now it seems more like this is kind of an organizer and not such the director. So all these clocks are kind of in rhythm with each other. And one of the things that happens as we age is all these clocks lose their rhythm. So you start having all your organs kind of on different times, and that leads to serious problems later. So when I say a clock, what does that mean? So we have to dive into the cell, and we have to go to our cells where we have a nucleus. This is where most of our DNA is housed, right? 23 chromosomes of 23andMe. And then there's outside the nucleus, which is the cytoplasm, which is where all the other stuff in the cell happens. But over the day, what happens is that there are two genes that are upregulated. They're called period and cryptochrome. And what happens is those go out into the broader cell, the cytoplasm, and as proteins, and they go do things. They turn things on, they turn things off. But what's important here is as these build up during the day, they start to form what's called a heterodimer. So they start to bind together, and when they bind together, they punch back into the nucleus and shut down their own production. So what you've got is this sort of inhibitory feedback loop. This is the molecular clock. There's another one that's over here, but I'm just going to focus on this one. And so if you think about this, again, you have these things produced, they build up over the day, then they come back in and shut themselves down. Now this clock is a little bit longer than 24 hours. It's about 24 and a half hours. Some people it's longer, some people it's shorter. So what happens? Like, why is that longer, and how come we still have 24-hour days, roughly? And that's because that is in sort of cooperation with our external environment. So our rhythm is set by everything around us. Light is the primary influencer of our circadian rhythms. These are all called Zeitgebers. So these are things that influence our circadian rhythms. So light comes in, that is setting our clock. So is the timing of when we eat. So is the timing of when we're active. So all these things, along with our molecular clock, give us our circadian rhythm. And so what's happening at night is hopefully sleep. And it's interesting in today's society, or maybe yesterday's society and before that, sleep has always been the thing that's treated as an option, right? Like, oh, I have a deadline, I'll just not sleep tonight, or I'll cut back on sleep, don't worry, I'll catch up on sleep later. Sleep's not an option, okay? Of those three things I showed you, sleep, exercise, and diet, sleep is the one that will kill you fastest if you don't get it. So you need sleep, it's really important. And everything sleeps, right? Giraffes sleep, they take power naps, like 20 minutes at a time, because they have to avoid predators. Albatrosses sleep while they fly for months at a time. They sleep while they're flying. Ants sleep. Anywhere from like 10 to 20% of an ant colony is sleeping at a time. So they kind of take shifts. They take little power naps. And so they're taking naps. And then sea creatures like dolphins sleep by turning one side of the brain on and one side of their brain off so they can stay alive and breathe. So if they can do it, you can do it. Yeah. So don't sleep in. Don't give up on sleep. Okay, you need sleep for many things. And the dolphin story is kind of interesting, right? So one side of the brain shuts off, rests, and then the other side is active, and then they kind of go back and forth. Well, this feature is actually conserved in humans, and this is called the first night effect. So how often do people experience when you travel, you get really lousy sleep the first night? When you're in a hotel or a relative's house or wherever it is? This is known as the first night effect, because what happens is, and this is the data to support it, we've studied this in 35 people. And so one of the things I'm going to do is every time I show you data, I'm going to show you the size of the study. We're going to comment on whether it's a large study or a small study. There are limitations sometimes to small studies, but this was interesting. It was done in a sleep laboratory where people on the first night of sleep had a lot of brain arousal, so their brains were waking up, which calmed down on the second day. And it was restricted, it was mostly in the left side of the brain. So what happens is your brain senses, it knows you're in a new place. That place could be dangerous. So it wakes up a lot to kind of make sure that you're safe. So it might take a few days for you being in that new place to start to sleep well, because your brain senses that it's a safe place to be. So this is something that's left over from our sort of evolutionary legacy to animals that also do this switching. We get that too. Okay, so we're going to dive a little bit deeper in what happens during sleep. And a lot is happening in our bodies, and a lot is happening in our brains. And so while, I don't know, there are books and articles out there that say, what are the mysteries of sleep, and why do we sleep? And it's like, well, we know what happens when we sleep, so I don't think it's that mysterious. But we're gonna cover a lot here. So at night, our heart function fluctuates, and this is all really important to maintaining good health. So our systolic blood pressure and our diastolic blood pressure are lower at night. So this is a 24-hour day. This little box here is nighttime. Our heart rate drops. I think a lot of people might be wearing devices these days, so you probably know that your heart rate is low at night. That's good, it should be. And lower heart rate is generally very good, and that indicates good health. That's actually could be considered another vital sign, along with blood pressure and other things. At the hormone level, there are really important things going on, and I put here, these are keys to recovery, because these are things that happen only at night, and this is what does a lot of the repairs to our body, especially if you're an exerciser or you've done things throughout the day to impact your body. So this is showing us a 24-hour day. These dark bars are nighttime, and the light bars are daytime. You can see some times here. So in general, at night, our body produces melatonin. So I'm sure you're all familiar with the hormone melatonin, the quote-unquote sleep hormone. This is upregulated at night. It's an antioxidant. So it's something that's flooding your cells to take care of damage. Growth hormone is peaking at night. This is important for repairing damage, and it only peaks at night, and it only peaks at certain phases of sleep, which is what we're going to get to at the end of this talk. Cortisol, which is another important hormone for rebuilding muscle and bone and other things, is low at night, and it rises in the morning right when you're about to wake up. So this might be part of the waking process to wake you up, and we're going to get back to that too in an interesting way. And finally, testosterone also peaks. So these are all things that are important to your body's turning over, repair, taking care of things, and this only happens when you're sleeping. Even DNA repair, so we get a lot of damage to our cells, we get a lot of damage to our DNA, that also has a rhythm. So a lot of these things, I hope you're getting the sense of at night, your body is taking care of a lot of business. So you have to give it a chance to do these things. But what happens as we age? So this is, again, thinking about the entire circadian rhythm. As we age, the peaks and dips tend to become flatter or attenuated. So we're less active when we're aging. Our temperature fluctuations are lower. Our cortisol fluctuations become lower. We produce less melatonin and glucose. But another thing that happens is not only do we have lower fluctuations, but our timing shifts. So we start to have early shifting or late shifting of the timing. And so when these all start to become out of sync, this is in reaction to some of those body clocks starting to not work together. This is a natural part of aging. Luckily, there are ways to kind of reset your clock, and a lot of it's can be with light timing, when you wake up, having a consistent schedule, and we'll get to all those things later, but your body likes consistency, especially when it comes to timing of sleep, and that can help treat a lot of these things when your clocks become misaligned. And thinking about something like muscle health, which is the last talk I think I gave at this group, is when our circadian rhythms are disrupted, this really impacts our muscle health, which is critically important for maintaining our overall health. Muscle and strength have become a very important part of our focus when it comes to health and aging. So at the whole body level, our clocks become, they don't coordinate anymore. Our hormonal environment, so the hormones we produce, shift towards more breaking down of tissue and not building of tissue. So you no longer maintain this balance of building and breakdown of muscle, in this case, or even bone. And then this can lead to long-term decline of muscle, frailty, other things that we experience with aging. And so I want to focus a little bit more on muscle, because this is a really important part of aging and maintaining muscle, and resistance training has to be part of any exercise that you do. Over the day, our muscle goes through building and breakdown. So after we eat, we tend to build muscle, and then over time, we break down muscle, and we build muscle, we break down muscle. Similar to bone. Bone does this too. And this is a healthy, balanced state. But as we age, what happens is we tend to shift to less building and more breakdown. And this can lead, again, to muscle loss. Well, sleep has a dramatic effect in the short term, not just in the long term over years and decades, but in studies of people where they force sleep restriction. If if you compare a regular healthy sleeping time, you get a balance of muscle synthesis and breakdown. A simple 24-hour sleep deprivation or 5 nights of restricting sleep to 5 hours already kicks your muscle into declines in protein synthesis. So this whole daily fluctuation can be killed with just one night of an all-nighter or several nights of sleep restriction. So sleep is really powerful and something that we can, again, control and modify. This was a fun interventional study where they took 10 people. And by the way, all these studies are published. This is from literature that's available to researchers. A lot of it's available publicly. So if you want, at the end of this, when I put up my email, you're interested and you say, oh, I really want to learn more about a certain study, please email me and I can send you this information if you want to do a deep dive on your own or with me. This was a really kind of, I think, interesting and powerful study where they took 10 people who wanted to lose weight. So these were sedentary, overweight people. They were calorie restricted to lose weight, so 90% of the calories they needed, and did two simple interventions. The first intervention was what happens when you take people and let them sleep a healthy interval, so 8.5 hours of sleep a night. And in that condition, people lost weight. They lost equal amounts of fat and lean mass, muscle. You then wash those people out and you force them to have less sleep, and you look at the amount of weight loss. People preferentially lose muscle much more than fat. So this again is the power of sleep. In a weight loss condition, sleep causes loss of both muscle and fat, but short sleep again produces a bigger loss of muscle. And this is interesting because when you think about a lot of these new drugs on the market now that are GLP-1 inhibitors that are causing dramatic weight loss, the biggest concern with those is that a lot of that weight loss is muscle. So it's not fat, you're also losing muscle. And so there are a lot of concerns about long-term health coming out of the use of these drugs. So if that is the case, if you're on a drug like that and you're getting short sleep, you're really potentially hurting yourself.
What if you're getting normal sleep?
Well, then you're still losing muscle potentially even under normal sleep conditions because those medicines are causing weight loss in general and not preferential to fat. And so I think we're all experiencing changes in sleep. I certainly am as I age. But what are the things that happens, right? We all know we tend to wake up more. It takes longer to fall asleep. This could lead to daytime sleepiness and napping. But we also can develop a risk of clinical sleep conditions, things like sleep apnea. And then on the other side of things, we tend to sleep less, have lower sleep efficiency, and later we're going to talk about what's happening in our brains, but we really start to lose out on the critical periods of slow wave and REM sleep. And this also limits our capacity for recovery, because remember, I was showing you that the hormones that are important for recovery only happen during sleep. So we're kind of missing out. Yes?
Does the word recovery refer specifically to an injury from which you're recovering, or just average daily existence, recovering from that?
I'm using recovery from average daily existence, but it applies in any sort of injury recovery as well. Because if you have an injury and your body needs to rebuild, it needs these hormones in order to be active and to rebuild. So it really applies to both. But I want this to be something that everybody learns from, because we all need that nighttime recovery, whether or not you're an athlete or somebody who's working hard to walk up and down the stairs. We all need it. Part of this is motivated from a talk I gave, I don't know when I was here last, but a talk I gave years ago. About a year ago. And so the one question I get, and I ask myself this, is like, why am I waking up at like 3 a.m. every night? I'm waking up a lot. And there were people in the audience when I spoke here who were asking me about nocturia, and this is the need to go to the bathroom throughout the night. And they asked me, why is this happening? And I was like, well, I don't know, but I'll go ask my doctor friends, because I work with kidney physicians, and so I was like, what's the deal with nocturia? And they sent me a really nice review article, which I'm happy to share if anybody wants to email me. But I put this up here because there were so many questions the last time I spoke, and really nocturia, there are a lot of reasons for it, so it's why it's important to see a doctor about it. Hopefully you can find a kidney specialist to talk about it, but it could be as simple as your timing of fluid intake, or how well your body retains or balances it. If you're drinking a lot of water or some sort of substance before bed, you may have to go to the bathroom at night. So some of it could be behavior. A lot of it can be due to medications, especially medications with diuretic effects. So, if you're having problems, talk to your doctor. It could be medication related. It could be because of other conditions, especially like diabetes or hypertension or sleep apnea. And some of these are treated with medications with diuretic effects. And then it could be also something related to lower urinary tract symptoms. Maybe it's a UTI or other infection. So there could be a lot of reasons. And again, I put this up here because there were a lot of questions last time, so I want to circle back on that. And there's good data, or there's a good publication on this that I'm happy to share. It could be a hormonal issue. Menopause is really rough on sleep. And so it could be a hormone issue, and if that's the case, again, talk to your doctor, because there are ways to treat this. Something I've seen in the literature lately is it cortisol? Remember I showed you cortisol earlier, and I said, it's important for waking up? So I want to bring this back up. So if you think about this cortisol profile, it's lowest kind of right around bedtime, and then it starts to creep up. And cortisol is one of the things that is important for wakefulness. So this is one of the things that helps you wake up. And if you have a level that you reach to be wakeful, but that's shifting to an earlier time during the night because you're not getting this valley, meaning there's maybe some sort of stressor involved, like you're doom scrolling at night and you're super stressed and all your stress hormones are up, you might be hitting cortisol earlier because this is the level that you experience at a normal waking time. But if you're not getting this low kind of de-stress time, you might be hitting this peak earlier at night. This can happen potentially over and over. So this is one hypothesis around why we might be waking up earlier, is because cortisol, a stress hormone, which is important for body health. Just, you don't want it too much, you don't want too little, and you want it at the right time. And the right time's not 3 a.m., the right time's 6, 7, 8 a.m. when you prefer to wake up. So I thought this was kind of interesting, because at the end of the talk, when we get to sleep tips, one of them is de-stressing before bed. Easier said than done. All right, I'm going to show some more data. But before I do that, I'm going to take everyone through Epidemiology 101. So you will have advanced degrees by the end of my talk series. But this is important, and it's important not just for sleep or stuff I talk about. This is important for anybody who reads health literature or opens, something online and it tells you that the latest thing is what's going to make you live longer or whatever. Be skeptical, be wary, but also try and understand what they're selling you and what they're trying to tell you. So a lot of times, and I look at a lot of health literature, and I'll see a study to be like, study finds blueberries make you live forever, or something like that. Study finds, a study finds this, a study finds that. First of all, is that study in humans? Right? No, I'm not kidding, right? So you have to be really wary, because stuff that's published in mice or flies or worms can be published as a human clinical study. So look at that. But also, a lot of these studies that are observational, which I'll go through in a moment, are represented as causation. And that's a really important distinction here. So were the blueberries tested in a clinical trial, or was it just people who said they ate a lot of blueberries? So these are really important things. And so getting that out of an article might be difficult, but you have to be aware that sometimes science is misrepresented in very bad ways in the media. So there are two general study designs that my colleagues and I use when we're studying humans. One is called observational, and observational studies involve a lot of people with different backgrounds, and maybe you ask them questions or you measure things in them. But the key is you find associations between exposures, behaviors, and outcomes. So these are associations, things that are statistically linked, but may not be causational. Maybe somebody who drinks alcohol has a higher risk of some type of cancer, but that may be because they're also smokers. And so there are all these things that you can kind of learn through a study, but it's all association. If you want to understand causation, this intervention results in an outcome. You have to do what's called a clinical trial or some sort of intervention where the treatment is randomized. Some people get it, some people don't get it. You do the intervention and see what happens. Drug trials are very popular for this. And so this is where you can get the causation. Now the issue is that each of these study designs has limitations. So clinical trials are hard to do in large studies for a very long time. It's hard to do a clinical trial to see if somebody's going to live another 50 years. Like the study designers won't live that long. But you can find associations in large populations over long periods of time, collecting lots of data. So everything has its advantages and it also has its limitations, but just know that when you open that article about the blueberries, it may be an observational study that's represented as causational. So this happens a lot in popular literature. So again, Epidemiology 101, you're now going to be able to dissect all those articles that are showing up in your Google News or whatever it is. Okay, so my colleagues and I, we study sleep, and there are many ways to study sleep. And I think this is important because there are limits to how sleep is measured and what conclusions you can draw from those limitations. The easiest way is to ask questions. And so there's a questionnaire-based assessment of sleep. It's called the Pittsburgh Sleep Quality Index. There are other measures. And these are actually pretty good. And you can deploy these in thousands and thousands, hundreds of thousands of people. It's not very expensive, and you can generate lots of data from those and find associations, not causation, associations. Wearables are cheap and everywhere now. I'm sure a lot of people in the audience are wearing a wearable of some sort that's taking some sort of data on them. There are rings now that will collect heart rates and all sorts of stuff. We've been doing this in studies of thousands of people for many, many, many years. So we can find associations between wearable data and outcomes. And the gold standard is really what's called polysomnography, which is where you hook up electrodes all over the body. You can detect what's happening in the brain. You can measure breathing. You can measure heart rate. You can measure limb movements. This is the gold standard for deep studies of sleep and studies of deep sleep. But it's hard to do and it's expensive, and you can't do this for weeks at a time. These are usually studies of one night, maybe 2 nights. So the deeper the data you get, the harder it is to deploy in larger numbers of people. So there's always a trade-off. And I'm going to show you results from different study types to just start building a case. And you're already convinced that you should sleep, but underlying all this stuff is ways to improve your health through sleep, whether it's through timing or other things. Got it? So in the wearable world, again, a watch, a ring, or whatever it is, maybe even your phone is telling you this if you've got your phone on your hip 24 hours a day. What these devices are doing is they're measuring movements. So as you move around, you're generating these lines. If you look at multiple days in a person, essentially what happens is when people move, they generate these lines. And generally when they're sleeping, they produce fewer lines, and then during the day they produce more lines. And so this is how we can measure sleep in a very kind of simple way, but without getting too deep. So you can look at sleep time when a person goes to bed and when they wake up, how much time they spend actually not moving while they're in bed. This person was up a lot here. This person woke up a few times. Maybe their cortisol was high or they had to go to the bathroom or something. But also day to day, like how stable is their sleep and their timing. So this is the kind of stuff we can get from a wearable, and this can be converted into association studies with lots of outcomes. So for instance, the question I get a lot is, how much sleep should I get? And the answer generally is you should get as much as you need. Because some people need 6 hours of sleep and they're just fine. They're very functional and get on during the day. Maybe most people need 7 to 8 hours a day. The math for that adds up, as we'll see at the end of this talk. But some people need more sleep, and if that's what you need, that's what you need. But in general, when you look at large populations of people, not individuals, but large populations of people, we see that the lowest risk of mortality, so risk is higher up along this axis, we get the lowest risks around 7 hours of sleep per day. That goes for cardiovascular data, stroke data, heart disease. So all, it's all kind of converging around 7 hours a day. And when we start to look at polysomnography, the math is going to add up to why it's roughly 7 hours a day. But what's happening in these tails, right? So if you've got a 7 hour sleep, what happens is that people who tend to sleep very long tend to have more medical conditions. So that's a hallmark of people who are sick or having medical problems. And on the short slide, what ends up happening is these are people who have issues maybe with inflammation or other things. So they tend to have different health issues. So short sleep and long sleep aren't the same thing when it comes to the epidemiology of risk. You're getting different things on each tail. Yeah. Oh, hi.
So is that 7 hours straight without waking up? What if you're waking up?
That's a very good question. So this is only assessing time in bed that's counted as sleep. Sleep efficiency is what you're talking about, and I'm going to get to that one next. Because sleep quality is better than sleep quantity, meaning sleep in bed. Time in bed. Because a lot of this could be time in bed that you're not sleeping. And so quality is really critical to all that. So yes, we'll get to that one next. I saw another hand. Same question. Okay, great, thank you. So this is actually getting the slide. This one on the right is actually the question you had. So some of the things we can look at, if we go back to this, I want to show you this. So some of the things we can calculate is sleep efficiency. So in this interval where you're trying to sleep, how much time is actually not spent moving? And so you can calculate a percentage of that time which is spent sleeping and not sleeping. So that becomes sleep efficiency. It's a percent. And we can calculate that. And again, we've done this in thousands and thousands of people. And one of the cut points that we found is very important for lifespan and health is 80%. And it turns out that if you're spending more than 80% of your time in bed when you're trying to sleep as actually sleeping, that is better than having less than 80%. So what this is called is a survival curve. And so over time, how many people survive? So people with high efficiency survive longer and they tend to have a longer lifespan and have a better survival compared to people who have low sleep efficiency. The same thing actually happens for sleep latency. This is the amount of time it takes you to fall asleep. So short sleep latency is considered healthier than long sleep latency. So if you're in bed and it's taking you a very long time, that is a measure of some other process that is going wrong, and over time that can be bad for you, as we can see here, taking a long time falling asleep. has an association with shorter survival. I'll go there and then back here. Yeah.
So some people fall asleep very quickly. Some people can't. It's very difficult for some people to fall asleep. I happen to be able to fall asleep. And I noticed that like my mother could fall asleep, even when quickly. Or, you know, she didn't have the problem of falling asleep. And my mother was the same. It seems to be maybe genetic. I don't know. I'm interested in knowing why. What is it? Why is it that some people have a lot of problems, some people don't?
Well, it could be behavioral, in that, and so at the end of this talk, we're going to go through sleep training, and you're going to come out of here with a lot of guidance for what is best for improving sleep. Some of them are getting at your sleep environment, so maybe you have a good sleep environment, you have good sleep hygiene, so that's all modifiable behavior. But you hit on something which is really important, which there are a lot of genetic factors related to sleep as well. And also sleep problems like periodic leg movements and restless legs and things like that have a strong genetic component. There are also strong genetic indicators, which can be mutations in those genes I showed you before, like cryptochrome period. Some of those genes run in families, and those mutations could be leading to better sleep that's conserved in your family. So it could be environmental, it could be genetic, or you're just lucky. There's that too. Not everything has an explanation. Go to you.
Will you be addressing how naps might influence one's ability to fall asleep when you go to bed?
I can. All right, so napping is controversial in the research world, and I'm not a physician and I'm not a sleep physician, so I'm not giving medical advice because I can't, and I shouldn't. But my read of the literature is it depends on the kind of nap. So there's napping, which is related to poor nighttime sleep. So if you're having poor nighttime sleep, what happens is this phenomenon called sleep pressure builds over the day. And you get to a point where you cannot stay awake. And that can lead to end of the day napping, which then has a vicious cycle because you get that end of the day, late afternoon, early evening nap, you wake up, you can't get to bed, you can't go back to sleep that night. And so that is a vicious feedback. So that is one type of napping which is considered unhealthy that needs to be fixed with repairing your nighttime sleep habits, because that should take care of the daytime napping. Now there are other daytime naps which are completely benign, maybe even healthy, but those are ones that are paired with good nighttime sleep. So napping, again, that results from poor nighttime sleep tends to be a hallmark of, has bad outcomes. There is, the phenomenon of the early afternoon sleep, or maybe the 30-minute power nap or whatever it is. I don't think anybody's saying there's a problem with that. Does that help a little bit?
Yes.
Okay. You've been waiting for a long time, so.
Real quick, with the x-axis in here, 0 is
Weeks.
But the age of the person?
No, this is data, so this isn't a huge study, but these are weeks of survival.
Survival.
So death, time to death.
But is 0 starting at age 50? Because that's 1,000 weeks is about 20 years.
Right.
Yeah.
So what 20 years, where are the 20 years in this person's life?
They all die after 20 years.
They're all dead.
No, there's still follow-up. If they were all dead, they'd be down here to 0. So this is the percent people surviving. So after those 20 years, 40% of these people had died. Or no, I'm sorry, 60% of these had died and 80% of those had died. So this is the cumulative survival, percent of people still alive. Is that good? You understand?
And so the 0 point is different ages for the different people in the study.
I don't know if it's ages, it's time to death. So some people died at 300 weeks, some people died at 700 weeks, some people died at 900 weeks.
Start of the study?
From the start of the study, right. So the people in this, but I mean, these studies tend to be done in like people in their 50s and 60s, so that's why you can get a 20-year survival. So these aren't like teenagers or something like that. Okay, sorry. I study aging, so I assume everything starts around age 60 and 65 because most of our studies of aging, these cohorts that we build, are people that are 65 or 70 and older. So that's where my baseline usually is when I think about these things. So yeah, these are great questions because I'm assuming you all do what I do. Come on.
Yeah, speaking of sleep quality, like the sleep deprivation and the amount of time, the most difficult issue here comes with certain service workers, especially if you're in the medical industry, because a lot of these individuals have to work straight, 24-hour shifts, like a day after day after day, and it becomes a problem when someone who wants to get some sleep has to get up because someone got up in the middle of the night, and that not only breaks the sleep cycle, but it also puts them into immense pressure to okay, do I want to sleep again, or do I want to take care of this person because he or she is really having a health problem? How can someone in that difficult position regain all that sleep deficit? Because truthfully, this study right here is more than enlightening, to be honest with you. It's almost like, what's the benefit of having a nap in the middle, and then you can, use part of the nap to cover, quote unquote, the sleep deficit. Well, at the same time, you can also say, hey, I need some sleep at this time, so I'm gonna need someone else to cover it.
Right. So I think so you bring up many really important issues here. The first is you brought up this kind of issue of shift work, right? So shift workers face a problem, right? Because some nights you're awake all night, and some nights you get to sleep, like nurses and things. I'll get to your other questions in a moment, but the idea is that IARC, which is the International Research Institute based in France, so it's this International Research Institute, considers shift work a low-level carcinogen. Because work done by colleagues of mine when I was at Harvard studying nurses, they had this thing called the Nurses' Health Study. They looked at rhythms and showed that nurses who had lots of shift work had higher risk of breast cancer. And they weren't sure what the environmental factors could have been. It could be a lot of the things I've addressed here, we'll continue to address. They were trying to measure light levels because continual light, and this is going to be a hint, right? You need dark when you sleep. And continual light really messes with a lot of your circadian systems and hormones and things like that. So that could be one reason why shift work is considered a carcinogen. I had a colleague who is a sleep expert. He wanted to study this in auto workers who are shift workers. And when he asked the union if he could study it, they told him not if he ever wanted to see his family alive again. So unions don't want to know about this stuff, right? But I think getting to your point, you bring up actually a really important issue is what about caregiver health? And this is a much bigger topic that needs to be considered across healthcare and across the world. Who knows about telomeres? Telomere shortening, telomeres cap the ends of our chromosomes and they shorten over time and then the cell stops dividing. Well, the discoverers of telomeres first demonstrated how important they are in health in a study of caregivers. So it wasn't a study of long-lived people, it was caregivers who live in an extremely stressful environment. They had extreme telomere shortening for their ages. And so that's where this stress marker was first demonstrated as being important. Telomeres aren't a good marker of aging, they're a good marker of stress, period. To answer your specific question, I'm not a sleep doctor, so I'm not gonna give you advice on that, but I think that at some point you need to get sleep when you can get it, right? So it makes sense to me. But what happens, which is kind of interesting, and I might talk about this a little bit later with dementia, is if you become extremely sleep deprived, your body becomes pretty good at getting right to the stages that it needs to recover. So you get with this kind of compensation in people who have conditions that result in poor sleep. They go right to slow wave sleep, or they get right to REM sleep, because their bodies they're in survival mode. They have no choice. They don't have the luxury of 8 hours of getting through all the phases that we're going to cover in a minute. They don't have that luxury, so the brain kind of gets to where it needs to be sometimes. That's not healthy, right? You're going to learn here that you need full, uninterrupted sleep. But I understand this is a stressful situation, and that has to be helped with support if possible. But, and I'm going long on this topic, but it's interesting because I had a meeting today with the geriatrics group. I work at California Pacific Medical Center, and we have an ACE unit, which is all about taking care of people who are elderly. And one of the things we proposed to them is we want to study their caregivers as well as the patients. Because we think that that's really important, and we want to study markers of stress, and we want to understand their sleep, because we think that's really critical to understanding care for people who are sick, their caregivers, not just the patients. So this came up today, actually. So it's kind of interesting. But I'm glad you brought that up. Last one on accelerometry, but again, this is wearables. Sleep regularity is really important. Remember I said before that our bodies like consistency. They like to see the same thing every day. Sleep is one of these things that's really important to be, as much as possible. We all have exciting lives and probably need to do things at different times of night. But again, this is another one of these graphs where this is years over time, so based on a baseline, and percent of people surviving over time. And so what you can see here is people who have more consistent sleep, they tend to go to bed and wake up around the same time, tend to live longer than people who have more fragmented sleep and wake times. I mean, this is kind of a nightmare situation where you have somebody who's just kind of sleeping at all different hours of the day. And this is actually a hallmark of dementia. This is one thing that happens with dementia, is sleep is just completely irregular and unpredictable. And it's almost like there's no time of day when the person's not kind of in and out of sleep. And these people tend to not survive very long. Again, it's an association. We don't know if there's an underlying cause here or if this is causing it, but I can tell you that these circadian rhythms are way off. And it's not just lifespan, right? I talk a lot about lifespan because we have a lot of data on that. But one, summary here is that two of the strongest things that predict how long you are going to live are walking speed, your normal walking speed. It's good to be a fast walker. And yes, you can become a faster walker. And also your grip strength. So this goes back to the muscle, but also nerve function, blood flow, those things. Strength is also a very, very strong predictor of how long you're going to live. These two simple things get worse with short sleep, poor sleep efficiency. There was that comment about efficiency. And this other metric we call WASO, wake after sleep onset. It's related to sleep efficiency. It's how much time during your sleep are you actually awake, rolling around, stressing, or thinking about the thing you just read online before you try to go to sleep. These are all negatively associated with the strongest predictors of health and lifespan. So these are all long-term impacts of losing sleep. These impacts, the functions, and it's not just these are important for living another 40, 50, 60 years. These are important for daily existence, right? You want to be able to walk. You want to be able to do things with your body, right? So don't even think about the next 50 years. Think about today. Like, how do I want to be mobile. I want to go to Wonderfest, and I want to hang out with this guy, and all that stuff, right? So these are important now, not just for the future. But what's really cool in this study where they looked at 40 people, and they compared, they looked at sleep and something called psychomotor performance. This is a test of balance and your ability to kind of think and solve puzzles all at the same time. And so what they did was they compared the score of psychomotor performance. So this is good and this is bad, and kept keeping people up over 24 hours in continually testing them. And the comparison is, I don't know who they got to do this other side of the study, but I can find out who the investigators are for anybody who would like to join. But also look across blood alcohol concentrations to look at the same psychomotor performance. And it turns out that, again, this is just short-term impact, right? The legal limit of alcohol impairment, this performance on balance and cognitive function, is equivalent to 24 hours of sleep deprivation. So being up for 24 straight hours puts you in a similar kind of physical mental state as being at the legal limit of alcohol. So again, sleep is really, really amazing and important. But sleep also ages our brains really rapidly. And so there's there's a lot going on in the slide, but what happens to our brains as we age is they shrink in size, they lose certain types of gray matter, they develop sort of more gaps in them. So this is what an aging brain looks like, and this is what a healthy brain looks like. And people who had, over time, 2 to 3 consistent poor sleep characteristics, and this is on this list here, whether it's related to duration or quality or sleepiness during the day, had brains that were actually 2 years older than their chronological age. And people that had 3 or more of these actually tended to have 3.5-year older brains. And this is from 589 individuals. So this is just telling you, and these are people who are 40 years old. So early aging can happen in your brain if you've got poor sleep. And that's at a younger age. But also poor sleep is associated with higher levels of what's called beta amyloid. So this is one of the things that's suspected to be a problem in Alzheimer's disease. So you can see people who have over 6 to 7, or less than 6 hours of sleep consistently have more red, and this red is a measure of this beta amyloid. So again, this is a risk factor for the Alzheimer's form of dementia. Okay, we're gonna take a break. There's a lot of information there. This is my sleep guide. It's Dr. Seuss's The Sleep Book. There's a lot of good info in here. I recommend reading this before bed and not looking at the internet. So think about this. Everywhere, creatures have shut off their voices. They've all gone to bed in the beds of their choices. Right? Really, really good advice here. All right, so yes.
This may be irrelevant, but when you talk about sleeping and the quality of sleep, where do nightmares fit in?
That's a really interesting one. So I'm no dream expert, but we'll actually get to REM sleep in a minute, so maybe we can talk about that at that point. But there's a difference, I think, between sort of night terrors, which is actually a diagnosed condition where it's really horrifying to see videos of people with night terrors. Nightmares, I'll talk about dreaming in general, and maybe nightmares will be part of that, or maybe it won't. But we'll get to that in just a moment. But now I want to get to the brain, because we talked a little bit about brain age. I want to talk about what the function is, what's happening in your brain while you sleep, because you're already convinced it's good for your bodies, right? It's good for rebuilding, it's good for maintaining healthy grip strength and walking speed. So what does the polysomnography output look like? So we've got all these electrodes, so things stuck to your head and to your eyes and to your body, and they usually don't record data on the first night, because this is, talk about a first night effect. Like, you're in a different bed, and then you've got all this stuff stuck to you, and it's like, of course you're not going to sleep well, right? So they usually wait until they start actually collecting data. But then you start getting all these waves. So when I talk about slow wave sleep or other types of sleep, they're literally waves, because your brain is making electrochemical outputs. So this is actually electrical output. But we can also look at blood flow, we can look at breathing and heart rate and leg movements. So this is all that goes into a polysomnography, and this is why it's hard to do in tens of thousands of people over long periods of time. But what happens? So you're going to go to bed, you're going to go to sleep at your regular time because you're a good sleeper. And what's going to happen over that night? Because you're going to sleep a good 7 hours, right? Well, your brain goes through what are called cycles. And most people go through 5 cycles. Some maybe have 4, some maybe have 6. Maybe one night you have fewer than another. But generally your brain is cycling through different waves of sleep. Remember I showed you those waves? And you're going through, so this is a circle, right? So there's REM sleep, rapid eye movement. We're gonna talk about dreams in a minute. And then you go through light sleep, which is short waves, and then deep sleep, which is called slow waves. These are fast waves, these are slow waves. But the idea here is deep sleep happens earlier in the night, so the front end of sleep is loaded with this deep sleep. These are called slow wave sleep. The waves are slower. And sometimes it's called N3, but I call it deep sleep. And that's about 20% of our time in sleep. But then as you progress through the night, you start to pick up more REM sleep. And that's this kind of dreaming state. So what's happening during deep sleep? This is when most of that repair is happening, right? So growth hormone, cortisol, all those things are only happening during deep sleep. And so this is the most restful stage. Your heart rate's at its lowest, your blood pressure drops. This is when muscle, bone, immune system are all repaired. DNA repair and replication happens at this time because your body's not highly metabolic, so it's less quote unquote damaging. There's less metabolic input. Your brain is clearing waste, so your brain's taking out the garbage. Your brain is doing a lot during the day, and it's creating a lot of electrochemical damage, and so the neurons need to drain. And so what happens is the glial cells that are packed in and keeping your neurons in place kind of loosen the grip, so all this stuff can drain out of your brain. This is happening during deep sleep only. So this is why it's important to have uninterrupted, long sleep. And also this is when most of your long-term memory is formed. So during the day, everything you're learning is in short-term memory. It's in your hippocampus. During slow wave sleep, what you need to remember is uploaded to long-term in your prefrontal cortex. So you've got this upload of short-term to long-term memory happening at this stage of sleep. And so how is slow wave sleep related to aging? Well, as we age, the thing that changes the most, so if you look at the two other stages of sleep, and slow wave sleep and REM sleep, the thing that changes most as we age, so this is percent change per year, is slow wave sleep. So we're losing our ability to generate slow wave sleep as we age. And in fact, that speeds up as we age. So you lose more slow wave sleep as you get into later decades of life. And this may be either error, because there's a lot of error in this error bar. It could be that we're getting into an age where we're consolidating our sleep more. Getting back to my point to you is if we're losing a lot of sleep, we can get right to that sleep that we need to survive. But the message here is that we preferentially lose slow wave sleep as we age, and that generally increases with age. It speeds up. This also happens in dementia. So if you look at people with and without dementia, people with dementia tend to lose a lot more slow wave sleep than people who don't. And people who lose slow wave sleep tend to have a higher risk of dementia. So again, this is, goes back to when I showed you those beta amyloid pictures. This is the thing that builds up in the brain. Not the only thing causing it. We think that there are other proteins which are more important for developing Alzheimer's disease. But the idea is that it's not just that we're getting less of the slow wave sleep with the age. We're actually losing a lot more of it as we develop brain conditions like dementia. And what's interesting is this slow wave sleep. I talked to you about how this is the time we repair our bodies. This is the time where we clear out the junk from our brain. This is the time when all those good things happen. Slow wave sleep also protects against Alzheimer's related protein buildup. So if you have people here who have a lot of amyloid beta protein in their brains compared to people who don't, and you look at the amounts of slow wave sleep that they get, what this complex graph over here is showing you is that people with these brains, so they have a high risk of Alzheimer's because they've got more of this amyloid beta, on a memory test, people who get less slow wave sleep have worse performance on the test, but people who have more slow wave sleep, this is less slow wave sleep, more slow wave sleep, do better on a cognitive function test. So again, people who have the proteins that build up in the brain related to Alzheimer's, if they get good slow wave sleep, they can still perform well on a cognitive function memory test. So this acts as kind of like we call it reserve, meaning you can have a disease characteristic, you can have a disease pathology, and still perform well. That's reserve. I may have Alzheimer's proteins in my brain, but I'm still cognitively with it. That's reserve. So people who sleep well tend to have more reserve than people who don't. And what's interesting, people that don't have beta amyloid, you know, the slow wave sleep wasn't as impactful for them. It's still important, but it's like really important for people who've got, you know, early Alzheimer's. So now getting to REM sleep. So we talked about slow wave sleep, and I'm bringing it home here, by the way. This is the other stage of sleep you hear a lot about, the dreaming state, you know, whatever the case is. So this is not a restful time for your brain. Your brain's doing a lot of stuff during REM sleep. This is also important for learning and memory processing, but this is really critical. REM sleep is very critical for emotional health, emotional healing, processing kind of all the, you know, things that you face during the day that involve emotions. And so this is really critical to taking care of stress and having mental recovery. So this is your mental recovery. Deep sleep is your physical recovery. REM sleep is your mental recovery. And so if you kind of add up all the hours it takes to get through all these things, that's about 7 or 8 hours. That's why I said if you do the math on sleep, in general, this is why it's recommended to get 7-8 hours of sleep. And for some people, they can get all this, you know, healthy REM and deep sleep with fewer hours. Some people need longer hours. It's what you need, but in general, this is what people need. Now, dreaming is interesting because it's thought that dreaming is a way of, when we talk about processing memory, a way of your body or your brain kind of taking what it experienced that day and kind of mulling it over. And so there was really fascinating work done on dreaming where they had people play games like Tetris or do video games, and then they reported their dreams. And a lot of the people talked about how in their dreams they were doing Tetris, or in their dreams they were doing like the video game, like a ski game or something like that. But what happened is throughout the night, because they were waking them up to ask them about their dreams, throughout the night the dreams were getting kind of crazier, meaning the brain was playing with it. Like, oh, now I'm, you know, skiing through the kitchen, or, you know, other things are happening because your brain's working on it. It's chewing on the day before. So that could involve the nightmare process. Again, I don't know, I'm not a dream expert, but the idea is that your brain is processing the emotions and also the things it experienced that day. And I think that's part of it. And it's not just reliving it, it's playing with it. So that's why sometimes you wake up and oh my God, I have such a great idea. It might have been because your brain had vamped on what you did that day. Yes?
This might be a question that nobody's going to believe, but I have a lot of instances where I have dreams that come true. So they portend something that's going to happen. And it's happened many, many times to me with my children. I'll dream that there's going to be an accident, and then there is an accident. So I tell them that I dreamed it, so they need to be careful, and then that helps. And I'm just wondering if that is something that people talk about. I mean, because it happens a lot.
So, I don't know. Like, it's your experience. You know, I don't, honestly, we don't talk a lot about dreams specifically in our research. I'm sure there are tons of people who do specifically that. I don't know. I'm willing to say I don't know, because I don't know, but it's your experience. So I think there's something to it. So I don't know, we could figure out who the best people to talk to are about that, to be honest.
I did read a study of clairvoyance. That's called clairvoyance.
Clairvoyance. Do you know about that? Should you two meet up after this? No, I'm not kidding. I'm not making like fun of anybody here, but like.
No, I'm just telling her.
Oh, okay.
I know what it is.
You know what it is. Okay.
Precognitive
Okay.
dreams. It's like that, but I don't fits in with.
Yeah, it just,
with
I can tell you what your brain's doing generally during that REM phase, and it's these things I talked about, like kind of going over the past day's events, not tomorrow's events. I have a question there in the back.
This, in a general way, how are the different brain functions, REM sleep, deep sleep, correlated to the recovery that you've identified? In other words, you say deep sleep, that's fixing one thing,
Yep.
REM sleep, how do you correlate?
Well, it's because that's when those hormones are peaking. So that growth hormone is, even though I showed you a big thing that said growth hormone's high at night and low during the day, it's actually high at night during slow wave sleep. So it's not across all sleep phases, it's only during those phases. And these norepinephrine, I didn't point this out before, but during REM sleep, you can measure hormone levels, and so norepinephrine levels, which reduce stress, those things those are stress hormones. Those are decreased only during REM sleep. So we know that the things that are responsible for helping with physical repair and mental repair are up and down regulated during these specific phases. So that's where the correlation comes from.
I think I know what a nightmare is, but I'm afraid to ask, what is a night terror?
Oh, a night terror, this is people who have really well, I think it's accompanied in part by movements at night. So I know you probably go online and look up night terror and see videos of it, but it's people who are screaming at night and agitated and getting out of bed and moving around. It's really frightful to see. And there are sleep clinics and sleep physicians who try and treat that.
Thank you.
Yeah, it's really interesting. Hi.
So if someone is stuck in a situation where they're getting up every couple of hours, to go to the bathroom or whatever, what happens to do they go back to the beginning of these cycles, or do they have to start over again, or can they get back to some of these stages? In other words, what happens to these phases?
Yeah, that's a really important question because, right, we talked about sleep efficiency, and if you're not getting through this, then you're missing out on stuff. And so where you end up really sort of depends on where you left. It's like you can actually get right back to the phase that you were missing out on. So you can get back to slow wave, you can get back to REM, but it doesn't always happen. And sometimes it takes a long time to get back to sleep, which would start you back in the cycle again. So really, it's not a satisfying answer, but it depends, and it can be either one. But we were talking before about this gentleman's question. If you look at people with dementia, like severe dementia, they tend to actually get more deep sleep per unit of time than people who have healthier brains, and that's again because the brain goes to the thing it needs. So they consolidate their sleep. They get very little sleep, but that sleep they get is highly sort of rejuvenating. But you don't want to be there. Like you want to be the person who needs a longer night of sleep. Yes.
What phase would sleepwalking fit in?
That's a good question. I don't know. I'm imagining it would be REM sleep, like something that's less restful. Because during restful sleep, that's when your body's kind of turned off the switch that prevents your body from moving. So I'm going to guess REM, but I don't know. But if you want to email me after the talk, I can find that out. That's a good question. I don't know.
If someone is to take a sleeping pill, that push you into one cycle versus the other?
The information on sleep medication is all over the place because different sleep meds do different things, and different people. Well, thank you. And different people respond differently to sleep meds. One of the problems that's been shown with earlier sleep meds is they actually don't improve sleep. Certain classes, what they do is they make you forget that you had a bad night's sleep. So some are just things. No, I'm not kidding. Like this. So that's earlier sleep meds did that. But there is evidence out there to show that a lot of sleep medications actually don't improve these cycles. They just make you get more of this kind of intermediate zone of sleep. So you're not enhancing your slow wave sleep or your REM sleep. You're getting kind of filled with the junk food of sleep. That happens with several sleep meds. And on the sleep med thing, I work with really great epidemiologists who study sleep, who are doing what are called comparative effectiveness trials. So they have clinical trials, causation, where they have people who are on a sleep medicine, or they're getting cognitive behavioral therapy, so therapy instead of sleep meds, or both, and they all work equally well for improving sleep. So my recommendation, not as a physician, is to always go with something like therapy first, because cognitive behavioral therapy can be delivered online, and it is just as effective, the data show, as sleep medications for improving sleep. So I would always recommend going there first. And so I just wanted to show one data slide, and then we're going to get into sleep, our sleep class. So this REM sleep which is really important for stress and emotions and mental recovery. This is, what happens in people who have depression, like severe depression. And as you would expect, if you look at a control, this looks a lot like what I just showed you before. People getting several phases of REM sleep and several phases of deep sleep. This is slow wave sleep. You can see that they've got REM distributed across the night. What happens is in depression, you end up with fewer minutes of REM sleep. So even though you can see there are moments of REM sleep, they're just not getting enough. So again, this kind of goes along with the role of REM sleep in emotional health, and how this is really critical for depression as well. And also, I think adds hope in that if you can potentially treat sleep, you can maybe address some of these issues, right? Because again, I would always go for the behavioral intervention before medicine, if possible. All right, so here we are. We've learned everything that we need to know about sleep. So what should we do? Sleep for success. Oh, sorry, I have a question.
Are there ways to increase your slow wave sleep and REM sleep?
That should naturally come through like a good night's sleep. That should come through with a good night's sleep. There are interesting ways to move people in and out of phases of sleep, and you can do that with noise, actually. So it might be that, so I use a book sometimes to fall asleep, or I listen to books at night. I sometimes wonder if it's messing with my sleep, to be honest with you. But people who study sleep are able to bump study subjects in and out of different phases of sleep using sound. It's really pretty fascinating. So to get to your question, having overall healthy sleep should go a long way to improving REM and slow wave sleep, but also your sleep environment. So is it a noisy environment? Because that could be bumping you in and out of these different things. So have a quiet environment. Maybe don't be like me and put a book in or whatever to fall asleep. Or maybe if that's what you need, that's what you need. So it all just depends. We're all different. But all right. So you have to prepare for sleep. Yeah, question.
The last slide you had up, which was the first one that you had early on in
Yeah.
the program, of the three notions, exercise, sleep, and nutrition, you said that some people would consider a fourth, but you disagree.
No, I said I agree.
I thought you said you disagree, that community was not.
No, I agree completely that could be a fourth part of the pillar.
I misunderstood.
Yeah.
We heard you say that you disagree, but
Oh, I'm sorry.
I
No.
wasn't the only one.
No, I would. I think. Okay, I would agree that should be something that's added to this.
I was going to ask how you justify that with these so-called blue zones, which emphasize community, as I believe that they do.
They do, absolutely. So I would agree with what I said before, that it should be part of this. I mean, I could add it to the slide, but it is important. Blue zones are interesting because from a statistical point of view, meaning more 100-year-old people live in those zones, that's been showed to not actually be true. So most blue zones, all blue zones, are either fraudulent or data or record keeping errors. So if you look at places like Sardinia in Italy or something like that, before birth records were kept, you get lots of 100-year-olds there. The moment birth records are being kept, they have the same number of 100-year-olds as anybody else in the world. In some places, parents and relatives are kept alive in order to get Social Security benefits for them. So people are getting checks in the mail because they say their relative's still alive. So a lot of it is fraudulent, but those are the numbers. Those are the numbers. The lessons, that doesn't mean they're not healthier in those places, and the lessons from those places, I think, still stand. Being active, sleeping well, community. So again, I agree with you on that one. All those things still stand, and I think what's even more empowering is it doesn't mean that those people have a magic thing that we can't access. Like maybe it's in their DNA or it's in the water or whatever. No, we can do all the same things they do. Have a community, be active, eat a Mediterranean diet, whatever it is, and have a similar healthy lifestyle. So to me, it's empowering that those things don't actually exist as hotbeds of centenarians. So that's, to me, I kind of like that. And I like numbers, and I think it's fascinating how it's kind of related to fraud in some ways. So again, just like you prepare to go to work, or prepare to go to gym, or prepare to come to Wonderfest, you need to put the same thought and effort into sleep, right? So sleep for success, that's why I put this on here. And a lot of this is common sense, but still it's all of this that matters, right? So, is your bed comfortable? Are you hydrated throughout the day? So you don't want to go into the night dehydrated, so you're drinking a bunch of water, so you wake up, go to the bathroom all night. The dark, quiet, and cool room, we can talk about temperature in a minute, but quiet is important, because I was talking about, bumping in and out of different phases of sleep. Exercise during the day is going to help your sleep. A healthy diet. Remember I showed you circadian rhythms, right? This isn't the nighttime you, which is opposite of the daytime you. This is 24-hour you. So in order to set your circadian rhythm, you need plenty of daytime light. So if you live in a cave, you're not going to sleep well. You need to have light. You need to have sunlight, or at least one of those lights that mimics sunlight. Like those are very popular in Nordic countries. But you need light to set your circadian rhythm, especially early morning light. That's really important for setting a rhythm and should lead to better sleep. And remember we talked about consistency. So similar bed and wake times will lead to healthier sleep. One thing you can sort of hack, I don't really like that word, but you can use the body's natural temperature rhythm to also give it cues of when it's time to get ready for sleep. So during the day, your surface temperature is cool and your internal temperature is warm. That flips at night. So now your surface temperature starts to become warm and your internal temperature becomes cool. So why not give your body the hint to do these things, right? So maybe, if you're having a hard time sleeping, put on some socks or some gloves, or put on something warm to help your surface temperature follow those cues, or prompt it to follow its natural circadian cues for bedtime. In general, a cool room enhances sleep as well. So that's, these things are all, what you can take care of. Nighttime exposure to bright light, especially blue light, is bad, and it's probably pretty well known at this point that blue light inhibits melatonin production by 45 minutes to an hour in people, so you don't start producing melatonin for close to an hour until after you've turned off your computer or your phone or whatever. So don't lay in bed staring at your phone, doom scrolling, because it's bad for your cortisol. It's bad. Nighttime drugs and caffeine and alcohol, like bad choice for good sleep. Stress. Okay, don't stress prior to sleep. I'm going to stress about this slide. Late meals, so eating late will throw off your hormones. Oh, I have a question back there.
If you have nightshade on, say on your Kindle, is that still considered blue light?
I don't think that's blue light, no. Yeah, so the paper whites and some of those things don't have blue light. Yeah, so that's something that's not blue light. Like a screen like this is blue light.
So define late in this case. Let's say, are we referring to like after 8 p.m. or 9 p.m. or 10 p.m.? Because there are some cultures where late eating is actually the norm.
Right. So this is I'm gonna answer that question on the next slide, which happens to be my last one. So we can all rest after this because you're probably tired. And so late meals tend to be related to poor sleep because in general you're throwing off your hormone fluctuations. So you take in glucose, then you're releasing insulin, which should be going down at night. You should have glucose up at night. So anyways, your hormones get thrown off. And going to bed on a full stomach can tend to throw off your hormones. And so there's this rule that's out there, which I think, this kind of makes sense. It's called the 3-2-1 rule. Some people call it the 10-3-2-1 rule. But the 3-2-1 rule, this is getting directly to your question here. So 3 hours before bed, avoid alcohol and heavy meals. Maybe some tapas or something are fine, I don't know. But what this does is it really reduces the disruptive effects on sleep patterns, mostly through hormone fluctuations. 2 hours before bed, stop working or engaging in stimulating activities. Start de-stressing, right? Get off the internet, do something relaxing. And then talking about the 1 hour before bed, getting back to the light thing that I mentioned before, turning off your screens. And this is before you anticipate going to bed, right? So if I want to go to sleep at 10, then I have to subtract 3 from that, right? So I should probably stop having heavy meals at 7 or 8 o'clock if 11 o'clock is my goal. So this is on your goal of when you want to be asleep. And again, this is the one that will really attenuate your ability to produce melatonin, which will interfere with sleep. So that's the 3-2-1 rule. Some people add 10 to it for caffeine. So stop caffeine 10 hours before. But caffeine, there's such individual responses. Like some people can have coffee up until the time they go to bed and they're fine. So I don't add the 10 to this. But in general, this makes sense from a data point of view, but also from a practical point of view. And it's something that's easy to think about and remember. So those are a lot of things about how you can improve sleep, because just like other kinds of training, you also need to work on sleep. So tonight, when you go to bed, remember that 99 zillion 9 trillion and 2 creatures are sleeping. So how about you? Right. So thank you for being here. Thanks for asking such great questions. I don't have answers to all of them, but you can reach out to me and maybe we can come up with the answers together, and I'll be here to chat afterwards if you have any questions. Thank you.
Dr. Tranah is not only insightful, he's also quite kind, so I imagine he will be willing to hang around a bit to answer our personal questions. Final applause for each other, for Hopmonk, and most of all, for our speaker, Dr. Gregory Tranah. Yay for Wonderfest. Thank you. Yeah. All right, 2 weeks.